Yo, everybody. So, APUS recently launched their tokenomics, and with that, they also launched the minting process of APUS token. So, in this video, I'm basically I will be exploring that. So, let's see, connect as so. The usual process is like you have to connect the wallet, your EVM wallet, the one which you use to stake on rv.dev, I guess, mint, yeah, on which through which you use to stake over here. So this wallet is the dev wallet, nothing that's why it won't be showcasing anything. But yeah, so the thing is, when you do that, it will say it will tell you how much SE ETH or DAI, if you select DAI, allocated to you, and how much APIS token you can build with that, mint with that, right? So it takes a quite a bit of time because it it first fetches the data using GraphQL from calling the dry run, then calculate it like you see. Now you can see like when SE8 is equals to this much of APIS token, and yeah, so it's 0%, it's zero available. I have, so right now over here it shows how much SE I have deposited into this particular contract where you deposit, right? And then over here it shows what you have allocated correctly. It's not transfer, it's just allocation allocated to the APIS network staking contract or like allocation contract or minting contract. So yeah, that's the whole thing. But now I was curious, like how this allocation is working and how by only signing a message on your MetaMask or on your Ethereum wallet, does this STETH, which the amount of STETH which you enter 0 or 100% or whatever in between, gets allocated to the APIS staking process. So that's why I've asked this APIS team to shed some light on this. And I asked them in a better way. It's better if you could just share me the repo, if it's possible for you guys. And they were happy to do that. So that's thank you for that. It's a complete public repo. APIS APIS Lab is APIS token, and over there you can see the whole code base and all the details. So yeah, in this video I will be learning and like understanding the code base of APIS token, how they have done that. So yep, let's get started. APIS token distribution analysis and implementation. Okay, 80% delegating, right? Pool substake, then first year 17%, then four-year halving. Okay, ecosystem testnet. Okay, and DG pool bootstrap. Got it. And liquidity 1% DG. All right. This document outlines the token release over 41 year of period for EO tokens. The token release for EO tokens over 41 year of period. Okay. In 41 years, I guess, yeah. Um, TGE at the time of TGE 8%, like 2, 7, and 2, 7, and 1. Yeah. So 8% will be distributed, and the first year 17% of the rest of the APIS token will be distributed. On the subsequent year, this much amount, this, like it's reducing by half. You can see with the 4 year of cap, right? Now, how to test Oh, that's awesome. They have given that already. Let me just install dependencies. Hmm. All test cases should be under spec folder, run test entry or npm run test. That's really cool. Hmm. Config module, load.js, imported from test.js. This is strange. Okay, we'll get back to it afterwards when we will be checking the code. Okay, every test file should end with spec.lua. Okay, allocate a depositor and every test file should be end with this. Every test file should contain how to deploy US process SQLite, cron 5 minutes, load, monitor, full. Now this is a AOS console inputs and outputs. Alright. Main DB return the database with the memory address. Return the object DB admin. It has a member variable called DB. Deposit. Return the database connected to deposits. Okay. Return the mint module. Members are mint related members. These functions can be found in mint.lua. Alright. Return the token module. Members are token related functions. Very well documented. Return the elevator module and distributor. Binding wallet test. Return the address of AO mint process. Let's see what is this. And you can see this AO dot link. Okay, it's a token itself. This mint. CNET. Test mint. This is coming from this token is doing it to itself. And this is another process. Okay. Let's see the source code. Okay, this is the AO token process. I'm just confused why it's bit. They have updated it quite a lot. I have read AO token process before, but this is updated quite a lot. Let's just copy it for the reference later. Right. Damn. Okay, this will be covered in separate video, but yeah, we definitely will be coming back to this code once again while exploring the code of APUS, because they must be calling some handlers if it's mentioned where, right? And initialize return. Okay, this one was for main. Okay, and this is now a deposit. New DB. Create a new client to process with the rewards table. Creatable operation. We can directly use db-admin as a parameter to create such an instance. Made, then they have mentioned everything. Types. Function used to add mint for target user record. You can directly use deposit to call the functions. You need to get a new instance of deposit. Get user by. Okay. User made recipient. Update mint for user. Okay. And get nice, nice, nice. This is really nice. Next comes by get by user. Yeah, we already saw this. Get all. Okay, we got all the. Yeah, nice. Get to allocate user. The function is on the records filter with the condition that mint of the record should be greater than 0 and recipient cannot be empty. Oh wow. So they have made every possible function which they might be using on the front end. Set upsert record. This function is can insert if the record with the recorder user doesn't, or update upsert test recipient mint. Really, really nice. And deposits clear mint. Oh damn. Uh, this is something like like something dangerous. If like it can be done. So if this is being done, then all the records will be changed. All the record will be lost. Though I'm definitely sure they must be storing it somewhere somewhere else, making a copy of it in a replica set. But yeah, and allocator, the function will calculate reward for each object in the deposit list. The reward will be allocated according to their mint. Hmm. I guess this is like damn. This is like calling this mint is the amount of SCE or die. No, it cannot be SCE or die because they would have been asking more. Okay, let's see what is this. Though it should mean that only. Binding wallet. This function will set recipient for the record with the user equals to the wallet. Okay, and return the recipient of the target user. Nice. Mint capacity. This is the 1 billion, I guess, or 100 million. It was 1 billion, yeah. 1 billion percentage at first stage. This is the total percentage of tokens that would be distributed at the very first stage, right? First, mint percentage, second stage. What about the rest of the one? Return the mint base. Okay, unit. Sorry. Yeah, unit. Mhm. Mm. Intervals per year. How does it? What's intervals per year? It says the amount of 5 minutes. I guess so. Let's check it out. Uh, yeah, how many minutes are there? And 12 months. Okay, now 365 days, 24 hours, 60 minutes. Am I doing something wrong? Because it the like it's 0.2. It's like inverse of 5. But why is that inverse of 5 instead of complete 5? Of course, I'm bad. So like total number of minutes upon this number of minutes, that will result return in 5, right? The hell, yes. 5, yeah. Now days per month. Hmm. Damn. 365.25. Intervals per month. Okay. Minted supply. This must be the okay. Like why is this minted supply is this? Let's see. Towards okay, it returns the minted supply. It's not the actual value, but yeah. And mint times. Okay. Mint cooldown. Return the cooldown second of mint. 300. Yeah. 5 into 60. 300. Last mint time. This is the timestamp. Okay. Current mode on or off. Okay. Um. Batch update. Mint report list. Update the rewards table according to the mint report. Get to all allocate user. Okay. Batch update. Mintus. 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 Okay. Hmm. Mint current mint amount. The coming mint cycle. Mint as per timestamp. Cooldown yet. Action balances. Total supply name. Ticker logo. Is return if TN has coming. Not sure what TN means. Token info. Okay. Balances. Balances. from AO.id returns the balance of that particular message, I guess, of that particular process. Nope. Data returns the balance. It is forbidden. Okay, they have made it forbidden. Um, transfer transfer the APIS token cannot until the end. Token generation event. Okay, yeah, there is a time limit. Like after a certain time, I guess then this APIS token will be transferable. Yeah, as far as I remember. Um, yeah, total supply. Get minted supply on token. Just nice. Okay, so this is that. What's the issue, by the way? Securing cron handlers. Okay, we'll get back to it afterwards. Now, let's see APIS token. What is this? Scripts. Main.lua. Initialization script for minting and handlers. Okay, in backup user. Let's add to this mint function. Okay, so this is quite good and sophisticated, though I have very basic question, but yeah, what it does is um, first is check whether the action is from cron or not. Then it check different modes. After that, it check the last mint time, and if it's equal to mint cooldown or not. So mint cooldown is 300. So like the last mint time and the difference between the current time is greater than equals to 300 or not. If it is, then it moves forward, and then it calculates how many times it needs to um, mint. So yeah, now it says suppose that it have to mint only one time in within a 5 minutes, right? What will happen is it will first check the current mint amount, how many token is already being minted. Let me just check. Okay. Uh, Calculate amount to be minted in the smallest denomination. So what it does is it calculates the current amount of tokens to be minted based on the remaining supply and percentages. Mint times. Okay, let me just go. Okay, just okay. Yeah, it's in the same file, right? So it's check the mint times intervals per year. Right, or intervals per year, whatever the how many times I have minted already done. If it's greater than, then PC, then it change it to the stage 2, right? After that, remaining supply mint capacity is 100 million and total minted supply, right? Whatever the supply has been minted already till now, right? And then release amount, like check how much amount needs to be released at the current time. It, like how much amount needs to be can be released. So like remaining supply, whatever the remaining supply of 1 year is into PCT. So like it will be uh, what we call it. PCT is the percentage of the supply, right? The remaining supply, the mint capacity is 1 billion. Number of tokens minted this. Now the first year minted supply is 17.25, right? So it will multiply with that and get the value number of APUS token that can be minted still. So this is the current amount. This is the amount which can be minted. Um, yeah, in this particular iteration. Okay. Now, just a second. Check this out. Yeah. So like every 5 minutes, 17.25% of the token needs to be minted of whatever the remaining supply of the token, right? For the first year needs to be minted. Now it's fact that and distributes that between everybody. Uh, just let's go once again and check out the yeah PCT is this hmm, first stage of this, right? 17%. And here we go, deposits with rewards. It's now calculate how much tokens need to be distributed among every deposit, every valid deposit, and then it check how much supply is being already minted, and over here, then it adds the reward, like deposit with reward. It adds to the balances of the APIS token, like the token balances, and after that, it's update the total minted value, like whatever the minted supply is being, by adding all the balances of every account, and then it logs the information at the very end. Let just me check the logger once. So log was saying, yeah, logger.info. We have some info. Okay, with color. Okay, it's a color. So logger.info and color in string format, and then it mints that. Uh, it just logs that in somewhere. Let me check it once more. Info. Okay, I guess it's saving somewhere. Just check what this. Mm, I meant this command. Okay, printing information. Division is mint times. Yeah, that's correct. So like it's printing, but I'm not sure. Might be might be something inbuilt in Lua, I guess, because I'm not able to see the print statement, or might be something else. So yeah, and then mint times increases the mint times. Then it clears the table. So now this is the query I would like to ask, where the APUS team is like, why this mint, like update rewards table, it's setting to 0, uh, all the mints. So I will ask them once, why is this being done? And then last minute time, that's cool. So it just updated the last minute time, and then it's collect the garbage. And at the very end, it says if there is any error, since it's a pcall function, right? Just try catch like in JavaScript. If it's there an error, then it will log that and then return OK on successful minting. So we can see it over here. I'm not sure whether this is not the one, but yeah, wherever the APUS token ID is, whatever the APUS token ID is, you can check it over there. Whenever this action is this is being called mint.mint, and is being called, it's doing that. Now mint.backup is this. I would like to see what's the meaning of mode and how it can be changed. If it's not here, say it somewhere else. Backup updated recipient. It's simple. get recipient balances, transfers total supply, that's all. So like mint, the token is, if I'm correct, it's a simple token, nothing, simple token contract, not something uh, big. And I guess this token contract is, yeah, it's similar to this. Yeah, so this is the same token contract, right? The ticker, let's see the ticker over here. Hmm. Okay, so ticker is not ticker and logo. All right, whatever. But it is quite small with respect to what your token look like. Your token have different functions also, which is required because it is interacting with the interacting uh, outside the ecosystem, right? Outside, like this is interacting with your EVM ecosystem. So that's why there are a number of checks, blocks, and every and whatnot. So that might be the case. But in this token, like it's pretty simple: token burn, mints, total supply, just transfer. I don't see like tokenomics module. Yeah, I don't I don't see any complicated or a big thing over here. Right, and then next is this is the metrics, like the latest data, nothing more than that, and initialized or not. So the majority of the portion was in the mint file. Uh, how it is being minted, right? Mm, with the percentage and everything. So that was the majority portion of it. Then okay, I haven't been to distributor, but yeah, let's check once. Distributor. I guess this is, yeah, courtesy wallet. So it just update the deposit stable, nothing different, and yeah, APIS. So yes, these are using the same AO token module. AO minting process, APIS stats used for tracking statics dynamically set from runtime config. Tracking statics. Statics might be the latest data, right? And I have seen this. Let's see the code which ones. Cycle info, get domain, get asset weight. Yeah, it's just sending the reports and everything. Asking for the reports and this stuff, I guess. This is the only code base, nothing more than that. So this is the APIS mint process, like and air receiver. Now this for the air process typically refers to the air instance ID dynamically the receiver address for the air process. So okay, let's see entity. This is strange. I'm not sure what is this. Flask. This is a user's address. Main cooldown start time. Okay. Liquidity pool address. This is the mm, pool bootstrap amount. Now test only will add all winners awards during the test period before TGE. 2% for all the contributors. Got it. Hmm. This and allocator. Yeah, it just calculates the proportionate amount which every depositor should receive. I'm still a bit confused. Like it might be on different side then. So like you can see update recipient. I need to understand how the recipient is changing its allocation. That's some inquiry I have. And this is deposits. ETH address log DBI when utils distributor. Nothing different. Okay. Static tokens are here. Static contract, which we were checking it over there, it's also here. Okay, vendors empty. Scripts. Let's first check out this async with log. Hmm. Still not able to see. Okay, let's just check out the dependencies. We check where they are using ethers. Like, does that be best to check? Though they might not be using ethers because this was something else, right? Yeah, powered by block native or some. This is of some other provider, EVM provider. So wallet provider, I mean. Let's check where they're using ethers. Nope, 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 nope. Command JSK. Generate ether accounts. No, this is just for the testing, I guess. Nothing more than that. So, yep. Okay, so right now it's not present here. If it is, I'm not able to see. Test deposit. Okay, this is the one. Deposit as a target. Wallet address. Alright. Results and message action. Test deposit. Token. Asset. User. Recipient target. Data amount plus result. Result messages. Okay, this is testing whether it's receiving or not. Whether it's being received. But send message to where exactly? These are the tags. Get it? Is this a target one? Recipient? I don't think so. It should be the one for the. Mm, no, this might be the one. This might be the target address. Hmm, quite strange. Okay, it's here. Sorry, my bad. It's something else. So send message. Okay, this send message actually takes the message and then send it like this. Connect message. AO mint process. This might be the test. Okay, so AO mint process, signer, data message, tags. Got it. So AO mint process. But why the AO mint process is accepting or the AO mint process is checking? I need to check that. Hmm. Okay, let's check how this is. Um, okay, let's go once again. Okay, I'm done. Where we got? I have test location. Yep. So let's see test deposit. Yeah, many deposits. Let's see this user dot update allocation. They own many of these. Yep, distributor set allocation table. Uh, it's not checking anything. What? Is it possible and why is this possible? No, no, no. There must be something else also. Mm, it's not getting. I'm not getting it right. Yeah, we'll ask them once uh, how they are able to change the value in this AO token process. Because okay, yep, I guess I know. I not I know, but I guess we can figure this out on own. It was configs and now statics main. This is the main process. This is the process of APUS token, right? As you can see, yep, is it not? Should be. So every 5 minutes. Okay, this is the start. This is it. Make message. Minted supply. Mint. When this mint has been called and by whom? Hmm. Okay. This is good enough, but yeah, I have some questions you'll ask. Very nice. Alright, I will check it out later once. Okay, I thought this was Elliot from La that what do you call it? Super Llama. No, no. Um, Lamaland. Yeah, thought he was that. But yeah, let's check it out later. Alright, guys, this is it. Learned a lot. Great contract by APUS and definitely great documentation by them. Just need to confirm how they are actually interacting on the front end. So as soon as that's confirmed, um, yeah, I might try to build my own APUS website. Oh yeah, there is one website. Uh, Sassy pages mint. How do I forget this? Oh damn, forgot this. It's the 8th. See, they are using Web3 on board uh, provider. Told you. Use your mint wallet, mint process. Get estimated if it's second. ठीक है, get allocation. Alright. The school. Get estimated. You get this. This is school. Okay. So I can send a message. Use each message. This must be the library from that. Quite a big function. I need to check this out. In utils. Oh, The data from message. So they are saying user update allocation is actually a function which can be called by. I, I'm not just understand how is this being called. If it's being called by that, shouldn't there be any check or something? Okay, using your connect and signer of the EVM wallet, you're sending all the data to the process. Got it? Okay, so we got it, I guess. So what's happening is, let me just show it. Yeah, yes, that would be better. And I guess I have it. Okay, now. Yep. So this user calls. Okay, we are just very big scale. Hmm. So this user calls hmm, user user update allocation. This function, this handler using EVM wallet. Right. He calls this handler using EVM wallet. And now this is AO main process. And at the same time, it also calls. So at the same time it calls. Let me just check that once more. Hmm. which is mint, right? And so mint over here. Use wallet, use this pin model. And yeah, like the thing is, like it should be calling a function. I'm not gonna go over the GitHub against. It will call a function on APUS mint process, uh, which will update the balance on over here. Like user, yes, there should be the function. It must be calling this on that handler, and that's there. Now, just to confirm one thing with this is it sending recipient user RV address, right? In this case, but same thing, APIS, I'm not sure which wallet or where this is getting actually stored. APIS wallet or process. So this will receive AO instead of the user. This is how actually it is working, and yeah, mm, that's it. I guess from my end. Yeah. Thank you guys. See you soon. Take care.